Dear students, I am Dr. Tamrakar from Bharati College of Engineering and Technology. I am teaching fluid machinery in BE 5th semester. Our next topic is the specific speed of centrifugal pump. The specific speed of centrifugal pump is defined as speed of geometrically similar pump which would deliver 1 cubic meter of liquid per second. 1 cubic meter of liquid per second against a head of 1 meter. Against a head of 1 meter. 1 meter is called specific speed. Generally, this is denoted by NS. Now, if the discharge Q for a centrifugal pump is given by the relation Q equal to area into velocity of flow. So this is pi dB into Vf, or Q is proportional to D into V into Vf. Here D is diameter of impeller of the pump and V is width of impeller. We know that B is proportional to D, proportional to dia. So we can write this can be given as equation 1, and we know V is proportional to D, so we can put this value here. So this Q is proportional to D square, putting this value there, into Vf. We also know that for tangential velocity is given by the tangential velocity U equal to pi dN by 60. This means that U is proportional to dN. This is equation 2. This is equation 3. Now, the tangential velocity U and velocity of flow Vf are related to the manometric head as U is proportional to Vf and Vf is proportional to square root of Hm, manometric head. This is equation 4. Substituting the value in equation 3 here, so root Hm is proportional to dN, or D is proportional to root Hm by N. Now, substituting the value of D in equation 2 here. So Q, equation 2. So Q is proportional to Hm by N square into Vf. into VF. Now, as we know, VF is proportional to HM. VF is proportional to HM. Here this VF is proportional to HM from equation 4. So we can write here Q is proportional to HM by N square into root VF is root HM. So this can be written as HM to the power 3 by 2 N square. So Q equal to K HM to the power 3 by 2 N square, where K is constant of proportionality. If HM equal to 1 meter, if HM equal to 1 meter and Q equal to 1 meter cube per second, Q equal to 1 meter cube per second, and at that time N becomes NS, specific speed. Then this is Q is 1, K HM is 1 to the power 3 by 2, and now N is NS. So K equal to NS square. This is NS square. So K equal to NS square. Substituting the value of K in equation 5, here the value of K, this is equation 5, here we substitute the value of K. So this Q, this equation 5, Q equal to NS square HM to the power 3 by 2 by N square So NS square equal to Q N square by HM to the power 3 by 2. So NS equal to square root of Q N square HM to the power 3 by 2, or this can be written as NS equal to N square root Q by HM to the power 3 by 4. 3 by 4. This is the specific speed of the centrifugal pump. Next topic is model testing of centrifugal pump. Before manufacturing a large size pump, there are models which are in completely similarity with the actual pump, also called prototype, were manufactured or made. Tests are conducted on the models and performance of prototype are predicted. The complete similarity between the model and actual pump prototype will exist if the following conditions are satisfied. First, specific speed of model equal to specific speed of prototype. Specific speed of model equal to specific speed of prototype. That means ns of model equal to ns of prototype, or n root q by hm to the power 3 by 4 of model is equal to n root q by hm to the power 3 by 4 of prototype. This is first equation. Second, tangential velocity is given by u equal to pi dn by 60, and we also know u is proportional to root hm. So root hm is proportional to dn. So root hm by dn equal to constant. This is equation second. Or root hm by dn of model equal to root hm by dn of prototype. This is equation third. Now, from this equation second, as we know, q is proportional to d square vf. Q is proportional to d square vf, because vf proportional to u proportional to dn, So in place of this dn, we have used this vf here. So in place of vf, we will use dn. So this q equal to d square into dn, that is equal to d की power 3 into n. This is proportional. Proportion d cube n. So q by d cube n is constant. So q by d cube n of model equal to q by d cube n of prototype. This is equation 4. Now next, Next is power of pump, that is P equal to rho G cube HM by 75, that is in horsepower. So here P is proportional to Q HM, or that P is also proportional to D Q into N HM, because Q is proportional to dq n. So we have replaced this dq n, and next dq n d square n square d square n square, because hm root hm is proportional to d n, putting the equation value of root hm. So this is equal to d to the power 5 n to the power 3, and this is power. So power by d to the power 5 n to the power 3 equal to constant. So P by d5 n3 of model equal to P by d to the power 5 n to the power 3 of prototype. This is the equations for model testing of the centrifugal pump. Now we will solve some more numericals on this topic which have been asked in the examination. Thank you.